This section will observe a whole wet mount preparation using 3 different techniques: bright field, dark field, and phase contrast. The first of these, bright field microscopy, is the form used in beginning biology courses. In bright field microscopy, the specimen appears dark against a bright background or field. You can see that the organism is bounded by a structure called a cell membrane. You can also rather easily detect the presence of the nucleus. Some anatomical details of the colorless amoeba, however, are impossible to see using bright field microscopy. Additional internal structures of the amoeba may be visualized by using the second method, called dark field microscopy. As the name suggests, you now see the specimen as a bright object against a dark background. In dark field, an opaque disc is placed underneath the condenser lens so that only light that is scattered by objects on the slide can reach the eye. Instead of coming up through the specimen, the light is reflected by particles on the slide. Observe the nucleus and food vacuoles, the ectoplasm, which is the rigid outer part of the protoplasm, containing little cellular structure, and the endoplasm, which is the more fluid inner part that contains most of the cellular structure. Please remember that when using dark field optics, any dirt or dust on your slide or specimen will shine just as brightly as your object of interest. Make sure your slide is immaculately clean. A third method, known as phase contrast microscopy, uses yet another special condenser and objectives. This method provides an even more detailed, almost 3-dimensional image of the specimen due to phase relationships of light waves. As we can see here, the background is bright, but the specimen is seen in still greater detail. One of the major advantages of phase contrast microscopy is that living cells can be examined in their natural state without being killed, fixed, and stained. As a result, the dynamics of ongoing biological processes in live cells can be observed and recorded in high contrast with the sharp clarity of minute specimen detail. Phase contrast microscopy utilizes a special condenser which eliminates certain waves of light that have been refracted by structures of the specimen. The more the refraction, the more light that is eliminated, thus causing the object to appear darker with greater contrast than the surrounding area. This allows the specimen to be seen in greater detail.